All right, first thing I want you to do on page 7 is just copy in those probabilities. These are the probabilities from yesterday. Do you guys remember the card that you got with your daily wages on it? So these are the probabilities. We had 22 people present yesterday. 1 person received $1 per hour. 4 people received $5 per hour. 6 people received $7 per hour, and so on and so forth. So our probabilities are all out of 22. I want you guys to use either the app on your phone or use one of the graphing calculators to find the mean and the standard deviation. You guys want me to walk through how to find mean and standard deviation using the calculator again? Okay, if you need a tutorial, follow along. If not, work on it on your own. All right, so on the graphing calculator, if you're going to calculate the mean and the standard deviation, first thing you need to do is go to Stat. You go to Edit. If you need to clear out the list, you go up and highlight the name of the list, hit Clear and Enter. Go over to the next list, up, Clear, and Enter. We're going to enter the possible values for X here. So this would be the possible dollar amounts. You could have gotten $1, $5, $7, 10, 15, or 25. And then over in list number 2, we're going to put the probabilities here. You can enter these as fractions. Just use the division symbol. So 1 out of 22. The calculator will automatically turn that into a decimal for us. And then we had 4 out of 22. And then, sorry, I'm going to look at your thing real quick. 6722, thank you. 6 out of 22, 7 out of 22, 2 out of 22, and 2 out of 22. Once you have those values in your list, so list number 1 is the possible values for X, list number 2 is the probabilities. You hit Stat again, you go over to Calc. We want 1 variable stats, so option number 1. List should say L1. Frequency list should say L2. That's your probabilities. Then you go to Calculate. X bar is your mean. And sigma X is your standard deviation. So 9.68 for our mean and 5.77 for our standard deviation. And we typically use mu to represent the mean and sigma to represent the standard deviation. I thought we got all that out yesterday. You should see the discussion on the AP teachers boards that I'm on. Oh my goodness, all of them, they're like, I thought I was going to get away with it, but instead. Sorry, I don't have time right now, my apologies. All right, and then we want to make a histogram of this. So we need to label the y-axis. You can do that using fractions or using decimals. I decided to go with decimals because we had one that was 7 out of 22, and if I used each mark as like 1 out of 22, 2 out of 22, 3 out of 22, I wasn't going to have quite enough room. So I counted using decimals. 1 out of 22 is just a little bit less than 5%. So at the $1 mark, I had a bar that goes almost up to the 0.05. And then at $5, that's about, it's like 0.17, 0.18, something like that, 4 out of 22. And then $7 was 6 out of 22. Notice my bars aren't touching and they're not very wide. Why is that? It's discrete. There's gaps between the numbers. And there's large gaps between the numbers. Like between 1 and 5, I wouldn't make my bars really wide, or it's spanning from 1 all the way up to 4 if I make the bar really wide. 7 out of 22 is a little bit higher than $7. And then my last two look like this. And the height of the bar, again, is being determined by the probabilities here. All right, so you guys have all been working really hard since yesterday, since you got your daily wage. Boss is trying to decide what kind of a raise you're going to receive. So we've got a couple different options. You're either going to give everybody's either going to get $10 more than they were making yesterday, or we're going to double everybody's wages. Those are the two options. Let's figure out which one would be the best. Well, let's look at it. Let's look at number 2 here. If we add $10 to everybody's wage, what would the new possible wages be? 11, 15, 17, 20, 25, and 35. Would the probabilities change? No, everybody still has the same card. Now you're just making $10 per hour more than you did yesterday. So our probabilities stay exactly the same. That means my y-axis is going to stay the same. If the probabilities are staying the same, what would the histogram look like? Pretty much going to be the same. Is everything about it the same? My probabilities stayed the same here. We have the same overall shape. There is one thing that's different, though. The values down here on the x-axis. What did we start at on the other graph? The graph started at 0, so we could get our $1 on there. This one, I've scooted over, so we have shifted everything. So with this shift, I want you guys to calculate the new mean and the new standard deviation using your graphing calculator. So the probability list can stay the same, but your x value list needs to change. And after you calculate the new mean, new standard deviation, I want you to answer that question for how adding a constant affected the mean and the standard deviation. Has anybody calculated the new mean? You said 19.68? That's what I got too. And what about standard deviation? 5.77. So how did adding a constant affect the mean and the standard deviation? It increased the mean by how much? By 10, right? What happened to the standard deviation? Stayed exactly the same. Standard deviation did not change. The mean was increased by the exact same amount that we added onto all of those dollar figures. So we had the mean plus 10, and this is just the same sigma. I would like for you guys to try part B on your own now. Take about 4 minutes to do part B. If we get done in less than 4 minutes, that's great, because we don't have a lot of extra time. But I would like for you guys to do part B. Those two parts too. What are the possible wages if we double everybody's old wage? 2, 10, 14, 20, 30, and 50. Do the probabilities change? Nope. Probabilities stay exactly the same. Oops, that was the wrong thing. There we go. Since my probabilities stay the same, I'm going to leave my y-axis the same. What would the histogram look like? It's going to look the same. If my probabilities aren't changing, my histogram is going to look the same. What did change about that histogram, though? My x-axis. The original one went from 0 to 25, and now we're going from 0 to 50. So we've got a stretch here. What's the new mean? 19.36. What's the new standard deviation? 11.5, 11.54. How did multiplying by a constant affect the mean and the standard deviation? They both doubled. When we multiplied the old wages by 2, that multiplied my mean by 2, and it multiplied my standard deviation by 2. So I want you to think about the card that you got yesterday, your daily wage that you got yesterday. Which of these two options for a raise would you want? Option 1 or option 2? Ooh, I got some people picking 1, some people pick 2. You go with option 1? Tell me why. Wages are higher. What were you making yesterday? $7 per hour. So 17 is more than 14, right? Does anybody like option 2 better? Yeah? Why? You were making 25 an hour. So tell me why you like option 2 better. Absolutely. Anybody making 10 yesterday? Do you care which option? Doesn't make any difference. Doubling it, adding 10, same difference. So what we were just working on is called transforming random variables. If you want to flip it over on the back side. Transforming random variables. There's two kinds of transformations that we looked at, either adding or subtracting a constant, or multiplying or dividing by a constant. The shape stays the same regardless. Shape is going to stay the same. If we're adding or subtracting a constant, the center, that would be the mean or the median, you're just going to add or subtract whatever C is. The variability, range, IQR, standard deviation, variance, those all stay the same. But if we are multiplying or dividing, the center gets multiplied or divided by C. For my variability, almost all my measures of variability, you're just going to multiply or divide by C. For the range, the IQR, the standard deviation. The only one that's different is the variance. We don't use the variance very much, but the variance is the standard deviation squared. So if I would multiply the standard deviation by C, then for my variance, I would have to multiply by C squared, because it's standard deviation squared for the variance. So far, so good? All right. Let's look at the check your understanding. It says let X equal the number of billionaires in a randomly selected state. Based on current records, the probability distribution of X is as follows. Number of billionaires. Looks like 10% of the states have no billionaires living in them. 24% of the states have 1 billionaire. 2% of the states have 165 billionaires living there. Random curiosity, you guys want to take a guess about which state that is? That would be my guess too. That would be my best guess. I don't know, I didn't look it up, but right, I was going to say New York or California probably, or possibly Texas. If we were to make a histogram of just this data, what would it look like? There's going to be gaps. What would the overall shape be? Do you think it would be approximately symmetric? Do you think it would be skewed left, skewed right? Skewed right. Look what happens to these numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 56, 58, 118, 165. We're way out there on the x-axis now. Definitely skewed to the right. The random variable x has a mean of 12.68 and a standard deviation of 29.02. Suppose that there was a new national law passed that requires each billionaire to pay a $7,000 tax to their state. We're going to let y equal the tax money received by a randomly selected state. So if a state has 9 billionaires in it, how much tax money are they going to get? Every billionaire has to pay $7,000 in tax. For a state that has 9 billionaires living in it, how much tax money would the state receive? $63,000. 9 times 7,000. My random variable y is just 7,000 times my x's. This is a stretch. We already talked about the probability distribution of x, what this histogram would look like. If we were then to go in and do a probability distribution for y, how would the shapes compare? It's going to stay the same. They're both going to be skewed to the right. The probabilities stay the same, so the shape stays the same. What would the mean amount of tax money be? How would I calculate the mean amount of tax money? I know the mean amount of billionaires, that's right there. Multiply it by 7,000. What about standard deviation? Do the same thing. Take it and multiply it by 7,000. So what would the mean of y come out to be then? $88,760. What about the standard deviation of y? $203,140. That's a pretty big standard deviation. Why do you think the standard deviation is so large? Yeah. It's stretching. We took the old standard deviation, which was what, like 32 something, and we multiplied it by 7,000. Each state agrees to invest $20,000 of the tax money they receive to improve the roads. Therefore, the net amount, N, of money that a randomly selected state has left to spend is represented by this. My random variable, N, is equal to whatever y was, that's the amount of tax money they're going to get, minus 20,000. What would the shape of this new distribution look like? It's going to stay the same, exactly the same as before. It's still going to be skewed to the right. What would the mean of my new random variable N be? I heard 68,000 y. You're right. Yep, take the mean of y and minus 20,000 from it. We get 68,760. What would the standard deviation of the random variable N be? It's going to be exactly the same, 203,140. When we add or subtract a constant, the standard deviation doesn't change. It doesn't get more spread out. It doesn't get less spread out. The only thing that changes when we add or subtract is that the x-axis moves under our feet. When we multiply or divide, things get wider and narrower. We are down to like T-1 minute till the bell. I unfortunately don't have time to pass back the tests today, but that is my goal for tomorrow. We won't have homework to grade, so I should be able to pass those back tomorrow at the end of class as long as we stay on it. Homework is due Friday.